Okay, welcome everyone to the Stateless Implementers Call number 32. I will share the agenda in the chat. So as a summary in today's agenda, we have team updates as usual. I will be presenting some 7748 execution spec tests document and talk about that for a bit. Then we have two testing topic discussions. Then Carlos will be talking about post-quantum Berkeley. And Guillaume wanted to touch on Xcode copy behavior when targeting system contracts. So let's start with team updates. I can start. So I've been working a lot on EIP 7748 execution spec tests. These are basically the tree conversion. This is a tree conversion EIP. As we discussed in previous cycles, it's quite important that we have some confidence on people implementations of this EIP. So one of the ways of helping EL clients test their implementation is actually having execution spec tests because there are a lot of things to test, corner cases, things like that. So I decided to start working on this, and I will share more details later. Anybody else want to share team updates?
I think I can go next. So I'm just finalizing the transition implementation in Nethermind, and hopefully I'll be able to run the spec test by start of next week.
On Bezu's side, could you hear me? Yeah.
Yep. Yes.
Yeah. Okay. On Bezu's side, still working also on Stateless. We stopped to work on the Verkel cryptographic part. We are just implementing Stateless without this part. And in the transition, we have a first implementation. So thanks to Ignacio for his test, I was able to fix several issues in my implementation. And I'm trying to finish all of the HKs like that. When we'll have a DevNet in the future, it should be work. And I'm also waiting for the new test from Ignacio to detect if we have other problem in the implementation.
Good. I can go next. Ethereum JS. We began working on the conversion implementation using underlying like MPT and Verkel. We have pushed back a bit our target date for releasing that because we've been focused on that like the yearly release that we do. A lot of last minute work for that, but we're going to resume work on that this week. And hoping to be able to start iterating on the tests, maybe not next week, but the week after would be more realistic for us.
Anyone else want to share some updates? Okay, so then we can move to the next agenda item, which is a tree conversion test document and available fixtures. So I will present that a bit. It will be pretty quick, I think. But first, I will share my screen. Okay, hopefully you can see my screen.
Yeah.
Yes.
Yes, okay. So I will share the link in the chat first. So, okay, these tree conversion tests are pretty complex in the sense that there are a lot of things to cover. So I won't go through this document in detail, but the goal of this document is to really explain what we are testing and what is the status of the testing. So this helps, like first, it helps me to really organize the thoughts and really understand which are all the things that I should cover. And also, I think will be helpful in the future for the testing team to really understand like my thinking in going through all the test cases and just simply document things better than expecting them to read the Python tests, which can be confusing. So yeah, if I don't expect everyone to read all this, but if you want to have a sense or a sensation on like the main reasons why we need to test this carefully are you probably want to see these bullet points at the top of the document. I think that with that, anyone can build a good intuition of what can go wrong in the tree conversion. So basically, the rest of the document is trying to cover a lot of things that can happen in each bullet. I also added this big picture plan section, which I simply wrote some quick thoughts about how we can test the tree conversion in different steps. So for example, the first step is basically building this execution spec test that I've been talking about, letting EL clients run them to have some really quick way of testing that the implementation seems to be correct. And yeah, execution spec tests are really nice for building really weird cases that are really complicated to really simulate in real chains or devnets. So I think that after we have some reasonable coverage here and we feel confident, we can jump into maybe running a devnet, trying to bootstrap it with a reasonable amount of Genesis data in the MPT, so we can define maybe the AP will activate in some specific block or timestamp, and let all the clients go through it and see what happens. I suspect this is mostly for testing stuff that the execution spec tests can't really cover, like chain configurations and maybe the engine API on some stuff. But anyway, I kind of put 3 phases here. I don't think we really need to do all of them. I just wrote them for just as an idea. We can create this devnet with some synthetic data. We can generate some random account and contracts data. We can also try copying existing data from testnets. That's a bit more interesting. Or we can have some kind of randomly sample data from mainnet. I know that's like an idea. After running a devnet and seeing that things can like work correctly, we can do some kind of shallow fork of testnets or mainnets. So I don't know. I don't think it makes sense to go through all of these. Maybe it's a lot. Maybe after execution spec tests, we realize that running only one variant of this in a devnet is okay, and then we can jump directly to trying things on mainnet or something like that. So yeah, take this as like just as an idea that I have about like what is the big picture of how to move from one kind of test to the next. Basically, the rest of the document is describing multiple testing scenarios. So if you only want to see like on the high level, just read the title. So we have known partial account conversions, which basically means testing cases in which accounts are converted within a single block. So for example, EOA accounts are always converted in a single block. Contracts kind of depend. If they have not that many conversion units, can be converted in a single block, and things like that. Then we have partial account conversion, which start to be a bit more interesting, because if a contract is big enough, converting it fully will span multiple blocks. So it's important to cover all the cases in which there's like boundaries in the account conversion logic that can match exactly blocks or not. So yeah, if you want to know more about that, you can see it here. There are some code chunk strike correct accounting tests, because the way that the IP is constructed today, we always migrate the whole bytecode data in a single go, but we still account those transaction units to put a bound on the worst case. So I'm trying to cover that. There are some special accounts that we should cover, like accounts that we shouldn't migrate as defined in the IP, things like that. There are some really weird cases that can happen exactly at the block where the conversion ends. So it's really good to cover those. Then we have test cases where things start to get a bit more complicated. So for example, you have accounts that already had rights by previous transactions. So whenever you move the data, you have to be checking that you are not writing stale data. So there are a lot of things there. Then we have blocks where the account that you will be converting in that block also has a transaction in that same block that write to that same account. So yeah, some things there. And there's like another case, which is basically doing state accesses to check that actually the converted data is read correctly. Yeah, this is has a big overlap with EIP 7612, but I will talk about that maybe later. And finally, we have to do tests for reorgs and being sure that EL clients are managing the conversion internal state, like managed correctly whenever a reorg happens with the conversion progress. So yeah, this is a bit more advanced, and actually we need to do some testing framework changes to really support this kind of tests. But yeah, I think we will leave this to the end. But yeah, that's kind of a big picture of all these. I use emojis to signal which ones I already implemented, which ones are pending to implement, and yeah, which ones I can't implement because we have to do some testing framework changes. So all the ones that you see a green tick are ones that I already work on, and yeah, can share with all of you. So today, doing all these accounts for around 140-ish fixtures. I have already a zip file with those that I will share maybe in the Matrix channel or somewhere. Unfortunately, those can't be like included in these formal releases that we do, because to do all this work, I had to do some quick hacks in the testing framework and in Geth, because yeah, there are still some things that we have to support in the testing framework. So to not really be blocked with that, I have to do some changes there that we will eventually kind of formalize with Spencer. But yeah, I will share the file with you guys, and you can simply run the tests and we can see what happens. Bear in mind that there might be cases where Geth has a bug. So I already shared before, like around 88 tests with Karim, and he already ran those and he passed them. So there's some reasonable amount of certainty about some tests, but many other tests that I wrote after, it might be the case that Geth has a bug, and since Geth is being used for filling tests, that can happen. So whenever you see a failing test, don't assume that it's your fault. It might be Geth's fault. So yeah, let's just collaborate async and try to make progress and get some confidence. After that, we have like another client that fully passes the tests. Then yes, like there's a higher chance that anyone failing on a test means that your client has a bug. Yeah, I think that's it for this agenda item. I don't know if anyone has any question. Yes, Guillaume?
I don't have any question. I have a comment regarding the potential DevNet launch and also talking about bugs. There is currently a bug that was introduced in Geth, so it no longer like the shadow fork currently is broken. We know exactly where it was introduced, so it has to do with the serialization format we changed. All I'm saying is if you want to build some test net on your own to do your own testing as preparation for doing like such a shadow fork or a transitioning test net, Geth has a bug that needs to be investigated. It has been investigated. It needs to be fixed. Yeah, I hope to fix it shortly, but for your information, yeah, if it doesn't work, it's normal.
Any other question? If not, we can move to the next agenda item. Okay, so the next topic is EAP 7612, transaction writing to the contract storage log indirectly converts specific data. Okay, this is something that I will explain a bit better now. So when I was writing the test, I realized some facts that might not be surprising in hindsight, but I just wanted to surface here just to be sure that I get others' opinions around this topic. So the situation is the following. Let's assume that we have this overlay tree, so we have the frozen MPT with data, and we are using the new tree on top. Being Berkel or binary doesn't make a difference. And we have a transaction that writes to a contract storage slot. Okay, really simple case. So something that will happen, at least what happens in Geth, is that, okay, clearly this new storage slot, right, will happen in the new tree, because when the overlay tree is activated, any new write goes to the new tree. But this also indirectly means that the storage root of this contract will get updated, right? And this also means that the way Geth works will also migrate the account header to the new tree, which at first was somewhat surprising to me because I was expecting, okay, if a transaction only touches the storage slot of a contract, it will only write the storage slot to the new tree. But I get the point that since the storage root was also updated, it kind of interprets that, technically speaking, the account header is also touched. But it's a bit weird because the storage root is not a field that we have in the new tree, right? So actually this account header right in the new tree is exactly with the same data that is in the MPT. So, bucketing this as a conversion that happened because of a write is a bit hand wavy, right? So anyway, maybe it's a way that everyone agrees that how this should work. I think that would be the best for Geth. But yeah, I just wanted to surface this fact, which might not be intuitive. And yeah, I don't know if anyone else has any comments. That's mostly my point.
I do have a question. When you say you write something to the storage, and you said the storage root gets updated, that's the part I'm a bit confused about. And I should have asked that before. How, the storage root itself does not get updated, right? Because the MPT itself is frozen, and so there's no reason to update the state root. So yeah, I don't know. I'm confused by this. Could you please detail what you mean?
This is what Geth interprets that should happen in the current implementation of the overlay tree. So it detects that the storage root should change, and for that reason includes the account header as something that changed and should be refreshed.
Right. Okay. Yeah. So it's okay. Understood.
In any case, this is something that will become apparent whenever people run the tests. Because if your client is not doing this, clearly you won't agree on the new tree storage in the new tree root. So, I mean, eventually we will find out if anyone else doesn't agree with this, how this should behave. But I just wanted to raise this topic just for people to be aware.
Another question I have is there any alternative to doing what Geth does, really? Like in your mind, is there anything else that could be done? Because I can't think of any way to do it.
Yeah, actually not converting the account header, right? Because it didn't change.
Right. Yeah, okay. Yeah, that's true. We could do this. We could try to do this. Okay, understood.
So just to be sure I understood, so when you are writing a slot, you are migrating this account to the new tree, and the state root in the storage root in the participant tree will not be modified.
Right. So technically, it shouldn't be modified because the MPT is frozen, but the way that Geth decides on which things got touched is kind of still assuming that the MPT is kind of active in a way. So it considers that the account data is touched and is doing the write, because in theory the storage root should have changed, but actually the write happens in the new tree, but this field doesn't exist there. So there's this weird case. Yeah. Okay, so let's simply wait for people running the test, and we can double check if there's any other real client that doesn't agree with this, and we can talk about this again. I don't think it makes sense to maybe discuss it further. The next agenda item is testing framework support for pre-images. So this is a topic that we chat with Karim when he was doing some alpha testing of my fixtures, and he was raising the point that maybe it makes sense for the fixture to provide the pre-images for the tree conversion. Okay, so the way that Geth runs the test today is basically that whenever it receives the pre-state to run the tests, it records all the pre-images of the tree. So whenever they have to do the tree conversion logic, it already has the pre-images. Another possibility is that these pre-images are provided by the fixture JSON file, and you can simply ingest them and use them for the tree conversion. My take on this is that we shouldn't add this to the testing framework. I know that it might simplify some EL clients' logic, but I simply believe these pre-images are redundant data, because whenever you ingress the pre-state into your database for running the tests, you can actually do this recording. And yeah, I just want to prevent some extra blow up in the testing framework of just keep adding fields that can be avoided. Yes, Kajinder?
Yeah, sorry to just take the conversation back to the tree migration. So what do we think of having basically persistently migrating trees, where after every epoch we migrate the tree so that there is state expiry also going on? Basically the previous tree is frozen and then there is a new tree where things are getting migrated to. What do you think of that particular mechanism in respect to our work here?
I'm not sure I quite get what you are proposing. Is this related to testing or something else?
No. So this is basically that I'm proposing with regard to tree migration, and it's not me. I'm proposing, basically somebody else proposed, and I just remembered. So I'm just putting it out there that one way they said that one way basically to have the new trees is to have basically also to have state expiry along with the new mechanisms, is that every epochs we basically put in a new tree and expire and freeze the old tree, and then basically do the same migration mechanism each time we see something happening, some account or something touching, apart from the first migration that totally migrates the tree. But then there are these trees every some epochs that you create, and you freeze the old tree and sort of expire it. So what do we think of that mechanism with regard to the work that we want to do in the stateless?
I mean, I think there's a pretty strong agreement with everybody I talked to, at least, except maybe you now, but that we shouldn't do state expiry right off the bat. So yeah, I think that's going to be a big scare. It's going to scare a lot of people to do this, because you have to go through the transition somehow, and on top of that, so you have to handle like two-proof system, which is already huge on the RPC providers and every API that you can think of, and then on top of that, you need to implement the API to handle the state expiry. So that would be, that would be my opinion about this, and at least my understanding of everybody's opinion as well, that anything doing state expiry while the tree is being converted is a no-go.
No, I'm saying that once the tree is converted, then we basically consistently keep on expiring trees in this particular manner. I mean, this is just a state expiry and maybe an independent topic, but I want to know what we think of it in terms of since we are designing this migration mechanism, then basically it makes sense that it can be extended to do state expiry after obviously our migration is complete.
Yeah, I see. Yeah, is there a write-up with this? Because you say someone told you about that. So is there a write-up so that we can dig a bit and form an opinion?
I think Sophia only mentioned it in PRND group. So I'll check and get back to you on this.
So Sorry, I think Gajinder, I only caught like half of what you were saying. If we had a way to do state expiry with separate state trees per epoch, like was discussed, I don't know, 5 years ago, I think that we wouldn't migrate the old MPT, and that would be very nice, both because it's like a kind of an ideal form of state expiry, and you avoid having to do the migration. But that was ruled out a long time ago because address space extension or contraction is kind of like a UX nightmare. I've only seen one proposal of how to kind of avoid that and limit proof sizes for resurrection, but it was never really explored. So
Yeah, so I'm not talking now in the context of MPT, but I'm now basically talking in the context of the stateless tree, Verkle, or binary tree. So
right, but if
I mean,
if we had a viable way to do state expiry that way, then I think what we'd want to do is to not migrate the MPT at all because it saves you from having to do that. But there were other serious problems in doing that kind of state expiry in general, which is why it was rolled out back then. And the only work since has been the leaf level for Verkle. I still think there might be possible ways to make that work, but no one has really been working on it. I can link to sort of the last discussion of it. It's this external period registry thing where you keep a separate, much smaller binary tree tracking hot state.
yeah, basically, I was thinking of the same thing, how to sort of modify the proposal to just do that in the current in the new migrated tree, so that the pitfalls that you mentioned would anyway be avoided, and because we would have anyway migrated a tree out of MPT, so MPT pitfalls won't be there anymore.
No, I mean, I think the problems I'm talking about don't have to do with different tree types, because even back then it was proposed that you could freeze the old MPT and just make the new ones Verkle. I know Guillaume just mentioned that having two proof types, but I think that the bigger issue is that these proposals, all except that not really fleshed out one I just linked to, require modifying the address space in some way. And I think that's probably a hard no.
So basically modifying address space to indicate whether it has been frozen or not, because I don't understand how the address space is basically coming into the picture when we are talking about post-migration system for doing epoch level.
I think
migration, epoch level expiry.
I had to sort of piece this together from discussions and old write-ups, but I think it's to identify like which old tree state is in when you're resurrecting it as part of the proofs. Let me link to something else. My memory isn't really quite fresh on that. I think this is the most comprehensive summary of the different like approaches that involve separate state trees.
Thank you, Sophia. We'll check it out.
Yeah, so this is an interesting topic, and we should definitely come back to this in a further call with more time. I was actually talking about something else in the agenda, but I get that this topic is interesting. So let's try to also allocate maybe in the next call if people want to talk about this as like an alternative way of doing the tree conversion if we find some viable strategy. So coming back to what I was talking about the pre-images supporting the testing framework, I don't know if anyone has an opinion around that. If that's not the case, we can move to the next agenda item. Yes, Spencer?
Yeah, I just wanted to check. So, how does the pre-image differ from the pre-state in the fixtures of the tests?
So the pre-images are only, okay, let me think about this for a second. Yeah, I think will be mostly the same. I'm trying to think if there's some extra case, but yeah, I think it's mostly the same. Maybe it's like has a semantic difference, has a separate field. But like technically is what Geth does today is just take the pre-state and just use that information to have a separate database. So I don't think like formalizing the pre-images as a separate field to have a specific interpretation adds any value. Yeah. Okay. The next topic is something that Carlos asked to be added, which is post-quantum Merkle variants. Maybe Carlos, you want to talk about this?
Yeah, I'll try to not take too much time. So basically, when I've been revisiting a bit the reasons why we like Merkle and why we discarded Merkle, and there's quite a lot of the reasons why we like Merkle that no other alternative is giving us, like binary trees are not giving us small proof sizes. We lack the capability of aggregating the openings or having like decently sized openings. And the more we raise the gas limit and the more we're allowed to touch state within a single block, the worse it will become. So I basically started to think about what if we could make happen Merkle still and take profit of some of its properties, but actually just trying to replace IPA and the vector commitments for something that is actually post-quantum secure. So I've been like taking a look to the state of the art of the cryptographic papers and this kind of stuff, and I basically made this write-up, which I will try to publish today on its research. So far, I've been in touch with Arantxa from the research team and Giacomo Fenzi and some other authors, well-known authors from the SNARK and vector commitment landscape. And I think there's, like, while I've been researching that, it's obvious to me that there's more people that is actually looking into this, like far more than I expected and I anticipated for sure. And that does make me believe that it might not be a completely crazy thing to actually look at. It will also be nice in the sense that if we find this viable alternative, then a lot of the stuff that has been coded so far is still valid, namely some of the stuff, like, for instance, elliptic curve related things, we can completely throw it away and replace it with whatever it is. But general tree layout and interactions with it and all this kind of stuff, that should remain the same. So we could reuse quite some work, let's say. And yeah, the idea is to start testing the feasibility of that and try to get some benchmarks to actually see if it makes sense to invest more time on that and like consider it like a serious contender to actually propose an EIP or something, or instead we just discover that in fact there's not much to do and we can discard it and focus 100% on binary trees or whatever we want to go forward with. So yeah, don't expect anyone to have much questions for now, as the write-up is pretty extensive. But yeah, feel free to please give opinions or feedback or ask any questions or whatever. I'll be happy to chat about that.
Anyone wants to ask any question about this topic? We can come back to this in further C calls after people read the document, of course. Okay. So the last agenda item is a point raised by Guillaume, which is how Xcode copy behaves when the target is a system contract. Maybe Guillaume, you want to talk about this?
Yeah. So that comes from a fairly contentious PR created in the Guess repo by yours truly. There's the problem, which actually stems from the Guess team's insistence that we should be calling EVM, like the system contract should be called with the whole EVM overhead instead of just implementing the code directly, which is the intent of EIP 7709. But yeah, there's some pushback. Anyway, the point being that using the whole EVM system makes it more difficult to filter out which item should be added to the witness and not when you call system contracts. Now, there's one example, which is Xcode copy. What happens if you Xcode copy a system contract? So currently, the argument is that every stateless client knows about it, so there's no point in bloating the witness up with code we already know. The counter argument, which is pushed by Felix among other people, is that these are just regular contracts, and while you do this, for example, we also agree that if you decide to call any system contract with an address that is not the system address, the code should end up in the witness. But now if you do Xcode copy, it's just an instruction, and that instruction underneath calls a system contract. Sorry, wrong thing. If you call Xcode copy, it's an instruction, and it behaves like it needs either it needs to know that the system contract is a system contract and not copy it, or we need to just say, well, in that case, even though it's an instruction, and even though the stateless client knows about the system contract, or at least knows the code of the system contract, we are going to add the code to the witness. Yeah, Ignacio?
So just to understand, the current way that 4762 is written, if I recall correctly, is that if you do an Xcode copy in a system contract, the code will be in the witness.
Okay, that's not my understanding of the... So if that's the case, then there's no more problem, I would say. I mean, there's still a bug in Guess, but that's in Guess Master, but that's a different thing. If that is the way it's currently specified, then there's no problem. My understanding, though, because I found this bug while trying to sync the testnet with Guess Master, it seems that this is not how it's implemented, but maybe I got mixed up. Yeah, okay. Gajinder seems to say we should copy generate witness. Okay. I mean, I guess it's simpler, so I would be up for this. Okay, maybe at this point, the action point is for every client to verify what happens when an Xcode copy is done on the system contract. And if everybody agrees that then the system contract ends up in the witness, then that's the end of the story. And if that's not the case, either we make it explicit in the spec that this needs to happen, or or we change the spec to adapt to what we like, what I believe is the behavior on the testnet, which, okay, Ignacio seems to think is not the case. So yeah, just please verify your code bases and let me know.
Yeah, so I was reading this link that I shared in the chat, which is the system contract section of 4762, and says that apparently the only cases in which you do not add system contract bytecode is whenever you do a system call or resolve a precompile and opcode. It says, however, any other accesses and all rights should appear in the witness. So
Right, but this
maybe
is
some.
we are in the case of an opcode because it's Xcode hash. Sorry, Xcode copy.
Yes, but what does it mean? However, in any other access, all rights should appear in the witness.
So any other access? Sorry, which line are you looking at? System.
Yeah, any other accesses. What is referring to?
Oh, any other access refers to calling. For example, you call the system contract without, like, from a regular contract, not with like from a regular transaction, for example.
Okay.
But then we could just remove to resolve it. Yeah, we would have to go over all the opcodes, but presumably we could simply change the line to resolve a precompile / opcode, and then that would solve the problem. Yeah. Yeah. Okay, so yeah, I guess that's a spec change, but everybody seems to agree. So okay, Gajinder agrees. Tanishk, I don't know, but yeah, we should probably. Oh, and Karim, I don't know about Besu either, but I agree we should change this line. It's easier.
We will check.
Yep.
Okay. This was the last item in the agenda. I don't know if anyone else wants to ask a question or raise any other topic. If that's not the case, we can finish earlier. Okay, I think that's it. Thanks everyone. Let's see us next time.
Yeah.